Ah! Ah! Oh, hey there. I wasn't expecting company. I'm Professor Chen, Esquire, PhD in Bro Science. Today I want you to learn about probability.
Alan has never played Halo before. The probability that he kills Richard is 0.2. Let's see what happens. Clearly, the odds were with him on that one.
Before we get started, let me introduce you to some terms. An event is any outcome that can occur. Your sample space is a set of all possible events. Probability is the likelihood of something happening, calculated by the number of successes over the total number of events.
Now let's move on to conditional probability. The conditional probability of an event B is the probability that the event will occur given the knowledge that an event A has already occurred. This probability can be written as the probability of event B given event A. In the case where events A and B are independent, or where event A has no effect on the probability of event B, the conditional probability of an event B given event A is simply the probability of B. If events A and B are dependent, then in order to find the conditional probability of B given A, we can divide the probability of the intersection of events A and B by the probability of event A. For example, if a teacher gave her class 2 tests and 20% passed both tests and 50% passed the first test, and we want to find the percentage of those who passed the first test along with the second test, then we are trying to find the probability of those who passed the second test given that they passed the first test. In order to find the solution to this problem, we need to find the probability of the intersection of passing the first test and the second test, and then we can divide that by the probability of passing the first test. With this, we can find that 0.2 divided by 0.5 equals 0.4, or 40%. This means that 40% of those who passed the first test also passed the second test.
Muhammad Ali is a professional MMA fighter, training under the instruction of Rudolf Schiller. His use of equipment illustrates conditional probability in real life.
My gloves protect my hands while I'm working out. The probability that I break my hands is much lower when I have them on. Statistics is such a big part of my life.
Here's Muhammad Ali punching without his gloves on.
Oh!
Oh no! He's injured his hand.
Statistics is a... When describing the probability of more than one event, specific rules come into play. These rules are the multiplication and addition rules. The rules depend on whether the events are dependent or independent of each other. The first rule, the multiplication rule, refers to the probability that both event A and event B will occur. For independent events, events that do not affect one another, the formula to find the probability of both A and B occurring is the probability of A times the probability of B. In this example, A is rolling a 5 on a die and B is rolling a 1 on a die. These events are independent and the probability of each event occurring is 1/6. To find the probability of both A and B to occur, just simply multiply 1/6 and 1/6. The probability of rolling a 5 and a 3 is 1 over 36. For dependent events, the formula to find the probability of both A and B occurring is the probability of A times the probability of B given event A has occurred. In this example, there are 4 red balls and 5 yellow balls in a bag. We are drawing 2 balls out of the bag without replacement, so the probability of the second draw will be affected by the first draw. A is that the first ball will be red, and B is the second will be yellow. To find the probability of both occurring, multiply the probability of getting a red, which is 4/9, and the probability of getting a yellow, which is 5/8, because the red was not replaced after being taken out. The probability would then be 5/18. The second rule is the addition rule, which refers to the probability that either event A or B will occur. If the events A and B are mutually exclusive, meaning that they cannot happen at the same time, the formula for finding probability of A or B is the probability of A plus the probability of B. If the events of A and B are not mutually exclusive, then the formula is the probability of A plus the probability of B minus the probability of A and B occurring.
Coins are a good example of illustrating multiplication and addition rules. The probability of getting 2 heads is independent, so you multiply 1/2 the probability of getting 1 head by 1/2 to get 1/4. The probability of getting 2 heads or 2 tails is a combination of multiplication and addition rules. It is the probability of getting 2 heads, which is 1/4, plus the probability of getting 2 tails, which is also 1/4, so it's 1/2.
Permutations and combinations. Permutations are the number of ways you can choose a distinct order of k objects from a selection of n objects. This gives us the number of possible orders for the total selection of objects, or n factorial, from which we divide the number of possible orders for the total selection of objects not chosen, or n minus k factorial. This gives us npk equals n factorial divided by n minus k factorial. Combinations are the number of ways you can choose a non-distinct order of k objects from a selection of n objects. This gives us the number of possible orders for the total selection of the objects, or n factorial, from which we divide the number of possible orders for the total selection of objects not chosen, or n minus k factorial, and then dividing again by the total possible orders for the total selection of objects chosen, or k factorial. This gives us nck equals n factorial divided by n minus k factorial divided by k factorial. This makes combinations the same as a permutation divided by the factorial of the number of objects chosen. An example of combinations is binomial theorem, where the sum of the ways a number of a's can be chosen from a given amount of identical binomials multiplied is actually the number of the power of a looked for in the term chosen from the number of binomials multiplied. The values are the same when choosing the respective amount of b's instead, because it's the same as choosing which a's are not chosen, which is why Pascal's triangle is symmetrical.
I'm trying to hack into Richard's Power School to sign him up for Solder's Enhancement. I know his 5-digit username has distinct numbers, and I also know his password. I wonder how many combinations there are. Well, there are 10 digits, and I need 5 digits, so that's 10 permutation 5, which is 30,240 different combinations. Yes, got it.